Once again, I welcome to you all for effective and efficient electronics for excellence, through which we are continuously studying various subjects, and we have started the control system, and we have covered some portion of it, and then we are started another very important and brilliant subject, that is signals and systems, in which we have seen the very basic definition of signal and then classification of signals. Okay, and then now we are seeing about the elementary signals, or otherwise the standard signals that are normally applied to any given system, right? So there are many elementary test signals or standard signals are there. Okay, so out of those classifications of elementary test signals, the first and foremost is the unit impulse signal we are considered. And in the last presentation, we have seen the definition of a unit impulse function and how the unit impulse function is defined. That we have seen the unit impulse function, the unit impulse, the unit impulse function. This is what we have seen, and it is denoted by delta of t. Actually, it is denoted by delta of t, and this unit impulse function are also called as Dirac delta function. You have to remember Dirac delta function. This is very important function actually. Unit impulse function delta of t. This delta of t can also be called as Dirac delta function. Clear? So already we have seen the definition of this unit impulse function in the last presentation. That is delta of t. It is equal to, it is 1 for t equal to 0, and it is 0 otherwise. This is the definition of this unit impulse function or Dirac delta function. And we have seen some important properties also in the last presentation, and even we have seen one very important example, right? So in this presentation also, just I want to explain you some more examples on this unit impulse function. Thereby you will very clearly able to understand about this unit impulse function. And moreover, in your competitive examinations like GATE as well as UPSC's IAS examination and many other state and central technical competitive examinations, you will expect the questions, the problems on these impulse functions, and you will expect the theoretical part is very less basically, because GATE is absolutely, it is a problem oriented examination. You will not expect any theoretical, because directly you will be asked okay the questions based on the formulas, like that only. That's why you need to remember the important properties and the definitions as far as this unit impulse function is concerned. This I already very clearly explained to you in the previous presentation, right? So in this presentation I would like to solve few examples. So this is one of the very important question which is asked in GATE examination. This is asked in GATE examination 2010. For this is asked for E&I, electronic instrumentation branch. They have asked actually. So this is very, let us we consider it as an example. This is evaluate the following integral. Evaluate minus infinity to plus infinite. It is delta of t minus pi by 6 t minus pi by 6 into 6 times sine of t. This is asked in GATE examination. Okay, 2010 for E and I branch. They have asked this question. Evaluate this integral. Minus infinite to plus infinite delta of t minus pi by 6 into sine t dt. So how we can evaluate what will be the answer for this, right? So I will arrange a little bit. Okay, so here if you see, let us see the solution part of it. The solution. If you see this particular, so what is this actually? What is this and what is this? I already explained you in the last presentation. Okay, so this is nothing but your shifted function. This is nothing but your shifted impulse function. That is called your shifted impulse function. It is shifted impulse function. Normally, what is your delta? Delta of t is unit impulse function in general, whereas delta of t minus pi by 6 is the shifted impulse function, and the impulse function delta of t is shifted by pi by 6 units, you can say. Delta of t is shifted by pi by 6 units. Therefore, this is what your delta of t, basically shifted impulse function. This is 6 into sine of t, you can call it as your x of t. This is your actual signal. This is your impulse signal. This is your actual input signal x of t. This is the impulse signal. Therefore, what we have to do? So, you have to identify what is delta of t and what is x of t, and from delta of t, so from here, so delta of t minus pi by 6, how you can define? So, means that here your delta of t minus pi by 6, when this becomes, it becomes 1. Clear? This particular delta of t minus pi by 6 becomes 1. For what value? For t is equal to pi by 6. For t is equal to, if you substitute t value pi by 6, t minus pi by 6 is there in the bracket, t minus pi by 6 equal to 0, therefore t is equal to pi by 6. So t is equal to pi by 6, if you substitute here pi by 6 minus pi by 6, 0, means delta of 0. What is this actually in bracket? This is nothing but time t in general. So delta of t equal to 1. For what value of t equal to 1? 0. Means this particular time should be 0. In order to delta of t should be 1. So you must always remember that your time, your t will be 0. You must equate this to 0 in such a way that your delta of t value becomes 1. So this becomes 1. This must becomes to 1 when your this time becomes to 0. So according to that, when it will become 0? If t equal to pi by 6. If t is pi by 6, therefore your t is pi by 6. So this t is equal to pi by 6 value, you have to substitute in your x of t. That's it. If you substitute that t is equal to pi by 6 in the given your x of t, I will erase this. What is x of t here? What is x of t here? Because in order to give you very nice explanation, I am explaining little bit slowly. So thereby you will understand very clearly. X of t is nothing but 6 into sine of t. So this is your x of t. Now substitute wherever t is there, pi by 6 is substitute, means 6 into sine. It is, what is t? Pi by 6. Clear? This further equal to 6 into sine. What is pi? Pi is equal to your 180. Pi is 180 by 6, means 6 ones, 6, 3 zeros, 630, means it is 6 of sine 30. What is sine 30 value? This further equal to 6 into, what is sine 30? Sine 30, it is 1 by 2. 2 times 2 3s are, it is 3. Therefore, your answer is 3. Therefore, your answer is 3. This is your answer. So, if you integrate, if you evaluate that integral, you will have the answer as 3. Your answer is 3. That is what simple calculation. See how easy it is. How easy it is. Clear. So these kind of problems you will expect in your GATE examinations. Once if you know very well about the definition and how to evaluate it, then definitely you will enjoy the subject. Therefore, you need to do more practice actually. Therefore, you will understand it very clearly. And then one more example I want to explain you. So this is another example. This is another example. Evaluate this integral minus infinity to plus infinite. It is t cube plus t cube. Sorry, it is not t. It is 3. T cube plus 3 into delta of t dt. What is the integration value? Evaluate this integral. So the solution part, if you see, tell me what is the x of t and what is the impulse function. Already it is direct, it is given delta of t. This is impulse function. T cube plus t is your x of t. You must consider it as x of t. However, delta of t is already given. Your delta of t is delta of t. Therefore, write that x of t is equal to what? T cube plus 3. This is what your x of t. Then what is delta of t? Already delta of t is nothing but delta of t. And delta of t value becomes 1 for what value of t? T equal to 0. It is not shifted. It is direct actually. Therefore, for t is equal to 0, your delta becomes 1. Therefore means, okay, this t equal to 0 value, you substitute in x of t. Means wherever t is there, then you substitute 0 cube and it is 3. Therefore, obviously, here also you will get your answer as 3. So, the answer is 3 itself now. The integral becomes, your answer is 3 now. Clear? So, if you 3 is your answer. See how easy it is. Very, very nice subject actually. It is very beautiful concept actually. Right? And similarly, you can evaluate one more example. Minus infinity to plus infinity. Let us try this. It is sine of it is t square minus pi by 2 into delta of t dt. What will be the answer for this? Evaluate for this. This is the given integral. Means integral over minus infinity to plus infinite sine of t square minus pi by t into delta of t dt. Now how it could be? What could be the answer? So what is your x of t? Sine of t square minus pi by 2. This is what your x of t actually. And however, delta of t is there. It is given as delta of t already given. So it is as it is given. Therefore, here if you write x of t is equal to, it is sine of t square minus pi by t. And delta of t, as usual we know, delta of t equal to 1 for t equal to 0. So, for t equal to 0, it is 1. It becomes 1. Therefore, the t equal to 0 value you substitute here. In x of t, you need to substitute t equal to 0. Means sine of t square means 0 square minus pi by 2. This implies what you will get? It is sine of, tell me, 0 square means 0 minus pi by 2. Clear? It is sine of minus pi by 2. So, sine, is it even signal or odd signal? Sine signal, is it even or odd? I already explained this also in very beginning presentation of our signals and system subject. The sine signal is an example for it is a odd signal. It is a odd signal. Therefore, for any odd signal, okay, what is that actually? What is that actually? What is that actually? So sine of minus pi by 2 is equal to minus sine of pi by 2. Is it not? Minus sine of pi by 2. This is what? Odd signal. So it is minus pi by 2 is nothing but minus sine of pi by 2 because it is a odd signal. It is a odd signal. It is not even. Cos is even actually. Cos function cos is even whereas sine is odd. Therefore, for my odd, sine of minus theta is equal to minus sine theta. Therefore, for this, what will be the answer? Minus sine. What is pi? It is 180. It is 180 by 2. This is equal to minus sine. 180 by 2 is nothing but 90. What is sine 90? It is 1. Therefore, minus 1. That is your answer. Minus 1 is the answer. Minus 1 is the answer for this question. Clear? So, that is what the integral value. Okay. Likewise, you will get very simple examples on this basically. Okay. And you can solve any given examples based on that particular example actually. And I will explain you one more. Say for example, let us say one more example actually. Evaluate example, one more example. Let us say evaluate minus infinity to plus infinite t minus 2 is whole cube into delta of t minus 2 dt. Tell me what could be the answer for this? Solve. So if you solve this particular integral over this can integral over minus infinity to plus infinity t minus 2 whole cube delta of t minus 2 into dt. Here what is your x of t? T minus 2 cube is your x of t. Clear? So this is what your delta of t. Therefore in solution part if you write x of t is equal to t minus 2 whole cube is your x of t. It is, what is this actually? It is a shifted impulse function. So shifted impulse function. Therefore, delta of t minus 2 is a shifted impulse function. This impulse function becomes 1 for t is equal to 2. If you substitute t equal to 2 here, then it becomes 1. Thereby your t becomes 0. For t is equal to 2, your t becomes 0. For t equal to 0, delta value becomes 1. Clear? Therefore, for t equal to 2, therefore substitute the t equal to 2 in this x of t. Wherever t is there means 2 minus 2 whole cube. What is 2 minus 2? 0. Cube, nothing but your 0. So the answer is 0. That is the answer for this integral. Clear? I think you understood. I think this is answer is 0. Clear? Likewise you need to. So if you observe that in all these examples what I have till now explained, integral I am considering means here the impulse function is a continuous time signal impulse function, continuous time signal actually, or otherwise sometimes you can, the same is applicable for discrete time also. In discrete time you will get, instead of integral you will have summation sigma. Let us solve one example on this discrete time signal. We will solve one example on discrete time signal. So let us consider this particular. Evaluate sigma n is equal to minus infinity to plus infinity. It is e power 3 into n into delta of n minus 3. Say for example, the same impulse function, the same kind of problem will be asked for a discrete time signal. So in the discrete time example, they will ask you like this. Instead of integral, in discrete time, we will use sigma, or otherwise summation it will call. So summation or sigma. N, what is n here? Discrete time. Whereas in continuous time it is t, small t. In discrete time it is n. N equal to minus infinity to plus infinite. And the function is same. Here e power 3n is your x of n, and this is your shifted impulse function. Therefore, here you write x of n as e power 3n. This is your x of n, nothing but your signal. So what is shifted function? Delta of n minus 3 is your shifted impulse function, and this value becomes 1 for what value of n? N equal to 3 itself. So for n equal to 3, your delta function becomes 1, thereby t becomes 0. Clear? So for n equal to 3, therefore wherever n value is there in your input signal x of n, you substitute 3, means e power 3 into, what is your n value? 3. Therefore 3 into 3, 9. E power 9. That is what the answer for this question. E power 9. Therefore here the answer is e power 9. E power 9 is the answer. Like that. Like that. Like that. You have to solve. Clear? I think these examples are sufficient on this particular impulse function, and we will finish off this particular presentation here, and then we will see the next classifications of the elementary signals, and we will see some more examples on those elementary signals in our subsequent presentations. I hope that you have enjoyed about this unit impulse function and how to solve the given problem. Okay, hope you understood well. Okay, we'll meet you in the next presentation. See you.